Okay, so my presentation is related to the impact of flood events in Romania and geospatial approaches for risk assessment and proactive preparedness. So I will try to be very short. Sorry, just let me, because I cannot see. Okay, I will be very short in the introduction part. As my colleague presented, also in Romania, we have an increased frequency of floods. And actually, in Romania, floods are the most frequent natural hazard, posing significant risk to communities, infrastructure, and environment. Actually, Romania is the fourth country in Europe in terms of flood risk. And then this can be associated with the country's hydroclimatic characteristics, which are combined with anthropogenic factors such as urbanization or deforestation. So, of course, like in Europe, recently in Romania has experienced numerous severe floods, causing economic losses and human casualties. And these events emphasize the importance of proactive preparedness, effective flood risk management, and efficient hazard mapping. Okay. As my colleague presented, the World Bank estimated that the average annual expected damage of floods in Romania may add up to 1.7 billion, affecting up to 150 people every year. Flood risk in a rural area, particularly in the eastern and southern part of Romania, also have increased in the past years, and the frequency and severity of recent floods are also linked to these broader climate patterns. As Viorel presented, the heat waves and the changing rainfall patterns attributed to climate change that led all over Europe to stronger and more unpredictable storms. So some of the contributing factors can be associated with climate variability, and here we speak about intense precipitation. Then another important factor is the land use change, urbanization, deforestation. Moreover, many areas in Romania, especially in rural regions, have weak defense systems, which need to be improved. And moreover, we have this urban development in flooded area or in high-risk flood zone that, of course, will increase the exposure and the vulnerability. And I have here some examples of the floods that took place in the past years. And one important one is the one that was triggered by Storm Boris in 2024, which brought, so this storm brought these torrential rains to mainly in the eastern part of Romania, but the most affected counties were Galați and Vaslui. And this flood took place in September 14, where in less than 24 hours, we had 150 millimeters of rainfall per square meter and caused severe floods in these areas. The most affected county was Galați, which is also the case study of today, where the water depths reach up to 2 meters in some localities, and more than 6,000 homes were either damaged or destroyed by in this area. So here we have the map of the area. So most of these localities that were affected are situated in Geru catchment basin, and here we have the main rivers. And with yellow, I represented the built-up areas, so the localities, let's say, because there are small localities. And here I have the map with the flood risk map developed by the Romanian, the National Administration Romanian Waters. And this is the hazard map with a 100-year return period. And we can see with dark green the localities and the flooded areas, and we also can see the water depth. So these maps are part of a broader initiative by Romanian Water Administration to create this comprehensive flood hazard and risk map for Romania in compliance with the European Union's flood directive. Another example of floods are the floods from June 2023 that took place in the southern Romania and affected several counties there. The cause was again intense rainfall, and the most affected area we have this over 140 households that were flooded. And in some area, we had also over 100 liters of rainfall per square meters. So these events highlighted the need for proactive preparedness and accurate flood hazard mapping. And of course, that with the technology advancement, a wide range of tools, methods, and approaches have been developed, providing improved capabilities for flood risk assessment. And here we speak about geospatial data and remote sensing technology, and in particular, geographic information system. Because these tools enable the identification of this vulnerable area, real-time monitoring for flood extent, and can improve the risk assessment strategies. So by leveraging these technologies, authorities can improve early warning system, can optimize response efforts, and can develop more effective mitigation measures in order to reduce floods impact. Satellite imagery provides valuable data for monitoring and analyzing flood events and their impacts. And here we have some key parameters that can be extracted from satellite images. For instance, we can extract the flood extent for accurate identification and mapping of affected areas. We can extract the land use change in order to analyze the infrastructure modification over time. And of course, we can extract information related to vegetation and soil conditions, such as the normalized difference vegetation index, which is an important parameter which shows the vegetation density, which helps in to identify the susceptible areas to floods. And another parameter is related to soil moisture, and this parameter shows how much water in the soil can absorb before runoff begins. So high soil moisture level indicates reduced capacity for infiltration, increasing the likelihood of surface runoff, and of course the flooding. You see that there are a wide range of satellite products that are available, and one of them is PlanetScope, which provides high-resolution images with a resolution of about 3 meters. Allowing for detailed assessment of flood-affected areas, especially in urban and hard-to-reach regions. And here we go back to our case study. So I've downloaded these images for September 15, 2024 for our basin, and you can see that the image provide clear representation of the extent of flooding on that specific day, allowing for detailed analysis of this affected region, as you can see in the second picture. Then I overlap the area identified using these satellite images is the green area here, with the flood maps using hydraulic models that were developed by the National Administration Romanian Waters, which are, these maps are represented with blue. So you can see some discrepancies in data. The real observed floods area is more extensive than the predicted one. We assume that the return period is 1 year, 100 years for both, because the maps developed by the national administration represented in these figures have a 100-year return period, and the floods that took place last year also are representative for 100-year return period. So you can see some differences and in some areas these differences are quite large. Then, of course, we have Sentinel-1 and Sentinel-2, which are other satellite products that can provide valuable information for flood monitoring. They can be used for vegetation monitoring and land use change detection. Okay, I will be more short. So here, again, for our case study, we have the soil moisture that was extracted from Sentinel-1 and using the Google Earth engine in order to extract this data. And then we have the NDVI parameter. Again, these are parameters that can be used in order to identify susceptible areas to floods. Then we have the GIS tools and the multi-criterial techniques, which integrate different data for various sources. So basically, using these multi-criteria techniques, we can and also GIS tools can create these flood susceptible maps which highlight the high risk zones. And I put here a picture. It's not the same case study because the previous one it's not ready yet, but this is another case study where we use this multi-criteria model where we integrated different information regarding the DTM, the slope, the TWA index, and so on. So basically, we use these parameters that can influence the floods. And using weighting techniques, we've created this susceptibility map, which is showing us the more at-risk areas. So regarding the reducing flood risk impact, we've identified some problems. One was also explained by my colleague related to extreme weather events, which now are occurring with high frequency, intensity, and unpredictability. So the point is that instead of using these traditional flood forecasting methods, which rely on historical rainfall patterns and river discharge data, it's better to use in our analysis data-driven approaches, maybe integrate open access satellite data, AI-driven analysis in order to provide a better and more accurate analysis in some in some areas. Another problem is the rapid urbanization. So urban planning for flood risk reduction should adopt and integrate flood management approaches, and of course prevent the building in the flood-prone areas. And another important part is the public awareness and community involvement. In some regions, early warning system and the disaster drill are well established, helping communities prepare for potential flood events. And these systems allow for notification, giving people the chance to evacuate and so on. So this is also an important part of flood risk management, which is often not taken into consideration. So thank you for your attention.